Thank you for letting me join from a distance here. There are many reasons why that originally started, and it turns out that I have a cold, so you don't want me in the room today, so it worked out really nicely. I will be incredibly quick here since we're running a little bit late. Caitlin is in the room. She's going to be helping remind people of time, so she'll give a warning at 20 minutes and 25 minutes, and then I'll cut you off shortly after that with some questions. We do have 4 great presentations today, and to fit all of those into our allotted time, we will need to be prompt without me saying too many words. With that, I would like to introduce the first speaker, Lieutenant Colonel Dr. Brian Woolley, who's currently wears a number of hats at the JAIC to include managing the T&E Enclave and leading the smart sensor test and evaluation team. Dr. Woolley worked on his PhD at University of Central Florida, and his research has included a variety of things, including computer vision and navigation for UAVs. And in fact, before coming to the JAIC, he was the deputy director for the AFIT Autonomy and Navigation Center. Today, he's going to be talking about JAIC T&E Framework. So with no further words from me, I'll turn it over to Lieutenant Colonel Woolley.
All right, thank you very much, Chad. Appreciate that. Really, honestly, want to say it's a pleasure to be here really in person, right, after a couple of years of so much virtual interaction with people. And it's an honor to represent the JAIC and introduce some of the concepts and the work we've been doing to you all. It did occur to me at some point yesterday, or actually probably within the first 10 minutes of arriving here, that what the JAIC is may not be completely well known. So what I wanted to do is I'll start with a quick introduction of what the Joint Artificial Intelligence Center is intended to be, and then where it's going from there. And then I'll introduce you to some of the really good work. My name's not on here because, frankly, this isn't my work, right? I'm actually exercising it under the Smart Sensor program. But this has been an amalgamation of work from IDA folks, from MITRE, and from the teams and experiences that we've had through Dr. Pinellas and so forth, right? So I didn't actually put my name on here, but it's really great work, and I'm excited to see in engagement with the operational test environment. We'll talk more about this as we go along. Is that it's very, very good at systems engineering, systems integration, and there's a huge need for addressing how we're going to continually test AI in and autonomous systems and artificially intelligent systems moving forward. So that's really the big purpose. So quickly to talk about the JAIC and what its intended purpose is the mission. It was established by Congress in 2019 to accelerate the adoption of artificial intelligence throughout the DoD because it was identified as a strategic advantage for the United States. And so what the establishment of the JAIC did is it created a single senior official who can look across the whole landscape of what the services and combatant commands are doing with regards to artificial intelligence. And because it's kind of took a startup kind of mentality, it's really meant to be very agile. And I seem to be, there we go. I'll just keep moving the mouse around. That's what it will do. And then, so what the JAIC is doing is looking at how AI can be brought at scale, right? So I'm working on a particular project for the test and evaluation for Smart Sensor, but everything I do with regards to that project is not in order to make that project successful. It's really to look at the lessons learned, what the challenges are, and then turn those so that they can be as lessons learned and processes and things that are applicable to the entirety of the DoD. Right, so that the whole Department of Defense can benefit and leverage those. So any tools that we find are beneficial, we don't want those just to be used on one project. We want those to be applied on other projects in the future. The other thing we recognize is that artificial intelligence is going to be used across the whole stack of operations across the DoD. Right, from the bottom of the stack at the tactical level. Right, where we talk about something maybe using facial recognition or something, or target recognition at the very lowest level to make decisions in combat and in the moment, all the way upwards into the joint force, right, conducting operations across multi-domain warfare is a new emerging topic where we can use cross-service activities to create effects in the DoD space, or I'm sorry, in the operational space. Then you've got theater. You got theater-wide things might include logistics, right? Logistics is a tremendously powerful part that doesn't get all of the credit it's due. I bet none of you could name the director of your water resources, your waste management system in your area. And if you do happen to know who that person is, you probably live in a place like Flint, Michigan or something, where you're in the news for not the good reasons. So anyway, logistics is one of those undersung or unsung heroes of those sorts of things. But artificial intelligence can identify tremendous deviations or deviations from what you might be expecting. It might even be able to predict operational effects that can result from the lack of a delivery of something. So then all the way upwards into readiness and personnel management, that happens at the SecDef level. So artificial intelligence is going to be not just one of those things we see at the most macro level. So with that, I'm going to violate exactly what I'm saying here, but I just want to introduce kind of what the Jake was. So I'm going to violate that idea that AI is going to show up in all sorts of little spaces. This is typically what we think of when we think of artificial intelligence, right? We think about a single pilot flying with a loyal wingman, right? In what is what the Air Force is trying to conduct in Thank you. My brain failed me. Skyborg is an Air Force project to allow multiple loyal wingmen to fly along with a single pilot or team of pilots in order to conduct and amplify really their abilities in the combat space, right? Project human level decision making through automated systems into more and more dangerous and lethal areas or denied areas. With risking less human life and things like that. So this is typically what we think of when we talk about artificial intelligence. But it's definitely an amplification of human abilities. I can't tell you how many times I wish I could have automation just bring me like all of this dirty work that I do over and over and over and over, and it feels like so repetitious. All right, and that's where we want computers to amplify our abilities. I really we'll use an analog here from industry. This is no endorsement whatsoever. It's just what I was searching around on the internet for. And I found a really nice little article on how Waymo wants to apply multiple vehicles under the observation of a single safety driver. And really the motivation here in their case is that you have less, it takes fewer people to operate more things. I've seen in the shipping industry, they're talking about putting single pilots on FedEx, UPS type aircraft that are ferrying things across the way, or ferrying goods and logistics across the nation or across the pond. And so you have these long flights, and they're talking about having just one pilot on board. And so that takes a tremendous amount of augmentation. And in this case, we're talking about unmanned vehicles carrying passengers around, and you may have multiple vehicles overseen by a single person. And so that's kind of the idea there. So what does it mean when we have more and more systems that are doing more and more for us in the world? We have to put a pretty high bar of what is safety, what is important, what do we want there, what do we want to deploy. So we looked at these systems and we require that they have dependability, right? These systems ought to be dependable. We're going to put our lives in our hands or in their hands sometimes. I tell you, I'm still not very comfortable with that, honestly. We talk about it should be a robust system, right? It should act and behave kind of in the ways that we think that it ought to. It should be resilient, right? These such systems are going to encounter tremendous diversity in the environment. I was out over the summer at Yellowstone, and they had a small vehicle and an unmanned bus shuttling us around, but it was in a very constrained place. It only followed a certain path, and it came and went on the day. But in order to say that this bus can now travel throughout the park on like a 100-mile loop, that's a tremendous amount of resiliency it would have to have to varying conditions, people driving around it. Scalable, right? AI should be scalable. That means it should be able to operate in diverse situations. It should be applicable under various conditions, and it needs to be able to handle the amount of data that's coming at it. It's not going to be in a test lab, right? We're talking about hundreds and thousands and perhaps millions of data feeds coming at it in a way. And the interesting thing about scalability, this is a little bit of an aside, is what we're seeing now is we're seeing very specific and tailored instances of AI, right? When you get on a website is not just being hosted to thousands and millions of people. It may actually know who you are, and it's being tailored to your particular experience. And I think that's what we can expect from artificial intelligence systems in the future. So not just scalable, but they're also going to be tunable to the individuals working with them. And with that, there comes a responsibility for security, right? You have such systems that are I'll say intimate, right? They're really engaging with the most specific portions of what we're trying to do and amplify the work we're doing. And so these systems need to be secure, right? In a military setting, they should be operationally secure for operational reasons because life, limb is all at risk, right? In a medical medical setting, your privacy requires security, right? And in a financial sphere, your personal information is part of who you could be. I haven't spoken in a long time. I apologize. Your identity theft is a tremendous risk, right, in the financial sector, and so security is paramount when it comes to these things. And then trustworthy it means that it operates. And we'll talk about this in the human systems integration portion here in a second, is that trustworthiness means that you know when to trust the system. You can predict kind of how it should work and how it ought to work to meet your needs, and that you also understand the conditions, the operator understands the conditions which it ought not work appropriately. So with this level of complexity, I think a lot of people have some reservations, right? I said earlier that I'm a little bit reticent to put my family in an unmanned vehicle, right, and trust their safety to an autonomous system like that. All right. Well, I apologize. I got a little formatting issue here at the bottom, but basically these are just the ethical principles. So the DoD has established 5 ethical principles for the development of artificial intelligence. I think I'm really excited about this, right? They are definitely a great guide map and post to things that we should be looking at and asking ourselves, because people have a resistance to adopting technology because they don't know quite what it ought to do. So it's important that we establish trust, not just in the system blindly, but trustworthiness in when it should be operating appropriately and when it ought not to be operating appropriately. And that falls under the category of responsible. Equitable, we've already seen with bias that can encroach into AI systems, so that's important to look at. Traceability. Traceability is a key important piece, and I like transparency, and there are some talks on transparency here. Reliability, obviously AI systems should be reliable so that we know when they're working. And governable means that you have the ability to control whether they're working in the space or not working in the space. And if something goes wrong, that you can jump in and intervene. So anyway, so a lot of people have seen AI systems that working, and they've seen them sort of fail colossally, right? Have you ever heard of why is AI fragile? Why is AI so dumb, right? These are some headlines that I've come across along the way. And so some of the reason is that this XKCD meme or cartoon really captures it really well, is we often set out to apply AI to a problem, and we don't really, we just kind of throw a bunch of data at it. If we don't get the answer we want, we stir the pot, right? We tune some parameters, we change some things around, and then at some point it kind of looks like it's working, and so then we declare that it's working. And I'm kind of like a test and eval guy, and I've always been very suspicious. I think one of my first AI projects back in 2006, I did some evolution of robotic behaviors, and one of the first things I realized was it converged on solutions that I wasn't very satisfied with. Right? It solved the problem. It got a really high score, But what it did was it solved my math problem. But I didn't like how it was solving it. So anyway, so what I started to look under the hood at what it was doing, and I thought, man, the fragility of what it's discovering doesn't really match the concepts of the world that I thought that it would discover. I really had high hopes for what it would come up with. So I like being in the test and evaluation space because it allows me to poke questions at what did the AI really learn, right? What world model did it actually capture, and is it going to be usable and representative of the world? Because a lot of these systems, like we have here in this big pile of data and it's pumping out something, they're pattern recognition systems, right? They're making decisions about whether or not you're in one category or another, right, for machine learning. They're making decisions about whether you should pick one path or over another. And that's really governed by other mathematical forces. And those don't always match the way that we have a human understanding or a natural understanding of the world. And so in order for trustworthiness and for AI systems to be beneficial to humans, is humans almost have like a requirement that the system think like a human, right? But in fact, they're not, right? These are definitely not human thinking machines. They're mathematical models that are trying to represent they're trying to represent the real world. And so they often will violate what we have intuitive understandings of the world about, because they're solving math problems rather than making sort of human level decisions. Because there's a lot of stuff going on in our brains and our understanding of the world that we overlook, and we don't even understand ourselves. Okay, so anyway, I'm kind of getting on a little bit of a soapbox and a little bit theoretical here. So what I wanted to introduce was a little bit of a practical framework that we've been talking about at the Joint Artificial Intelligence Center about how you can develop artificial intelligence systems and how you can introduce testing into the process and what that kind of looks like on a practical level. Okay, so this is a framework that we've been looking at and exercising in some of the JAIC projects that have been going on. And what it shows here is that you start with mission requirements, right? Those are the kind of the easy ones. You talk to your warfighters, you talk to your operators, you talk to your senior leaders, and they tell you, these are my mission requirements. This is what I'm trying to achieve. And then you have to start translating things. You have to start saying, all right, do we think that AIs or technologies, artificial intelligence technologies, are the right tool to apply here, right, in order to bring this to bear? All right, my little clock I'm doing here is getting away from me. Okay, all right, I'm good on time. All right, so you start to look about AI development, and then you have to start thinking about, okay, I'm going to develop an AI for it. I'm going to employ it in a situation. And what we've found is that when it comes to artificial intelligence systems or machine learning systems, this disconnect between the way it ought to be operating in the real world and what it might actually be learning requires that test and evaluation be incorporated earlier, right? We often talk to people who think that AI is something that testing is something you tack on at the end. And there's a complaint that now we're going to test our systems, and don't you think I tested it thoroughly enough, or don't you think that we really looked into all of those things? You're just going to cause delays. These are a lot of the things that we hear around testing. But what we've actually found is that by incorporating testing activities throughout the development lifecycle and doing them in parallel and doing them alongside the development process, what we create is this there's an independent feedback loop, there's an independent evaluation. It's not a hostile, it shouldn't be a hostile, right? Nobody likes their homework being checked, right? I'll tell you, it's very uncomfortable. So we try to be very careful about bringing those insights back to the developers and saying, we've been looking at the data, we've been looking at the held out data, we've been looking at data sets that you don't have access to yet. And what we're finding is that there are some weaknesses and some oversights that could be addressed now. And by feeding that information back in before deployment and before it's actually reached the operators, they have the opportunity to sort of make those corrections. And so it is a little bit of an additional workload, right, to come in early on a project. But it also helps the test community develop their tools along the way, right? Rather than having to develop the tools here prior to deployment, well, my little cursor's not working, at the yellow arrow, right, at the way to the right, just before you reach out to operations, developing the testing tools is a significant lift. But we found that as we engage with teams earlier, we can understand the ontologies, we can start to develop tools for testing very far to the left in the beginning of the process. And then at that point, conducting testing is much more rapid. Right, we're able to conduct testing iteratively, incrementally, and as new iterations emerge, we're able to provide insights back to the developers and to the project owners as the project goes on. And then when it does reach into operations, we need to continually engage with the operators in order to get more feedback and more robust feedback and more detail about how it's operating within the actual operational environment. Because like we said, these systems need to be robust. And they're going to engage and encounter more and more diversity as their lifetime goes on. But we found that when we take this approach, we don't actually introduce the schedule delays that we thought might, or that people worry about being introduced by engaging with test and evaluation early. What we found is we've actually been able to find insights about the models and fail fast. Right? We talk about failing fast and failing early. We've been able to abandon approaches in the development cycle sooner than finding issues towards the right and closer to deployment, and that would be more disruptive. Okay, so this is the T&E framework. So a lot of these things I think many of you may already know or be in agreement with. But the T&E process that we've been looking at specifically with AI-enabled systems is in addition to some of the testing processes that are already there. Systems integration is probably the most robust portion of test that exists today. And operational test is the other very robust portion of the test community that already exists. The addition to this framework that Jake has found, and I'm going to focus on here in the last 10 minutes or so that I have to talk, is the algorithmic testing, right? When we talk about algorithmic testing, we're often talking about very detailed metrics, we're talking about very nuanced things. And in the computer vision space, and in the natural language processing space, and the optical character recognition space, there are very detailed things about precision and recall, and all those those are all very well established. But then we also go into a little higher level operational space around the algorithmic testing, and we don't know yet how to address automation. We don't know how to address the autonomous behaviors of a system that can move freely through a space. And so that's kind of an open conversation that we're having, but that falls into this algorithmic category. So there's a little highlight into that, things that are coming. And in the human systems portion, which is a new and rapidly expanding portion, is we're starting to realize that these AI-enabled systems, they're not just systems that we offload work to. They're partners, right? They're partnered with the human user, and they're, like I said, they're here to augment and expand their abilities. And so they really need to be looked at in a system and modeled as a system where it is human-machine teaming, right? And so we'll look at that here in a little bit too. The team at the Joint Artificial Intelligence Center has also augmented existing test master plans with some frameworks that include new sections for addressing test plans with regards to the algorithmic evaluation and the detailed evaluation during just held out data sets, through modeling and simulation, as well as through human trials and surveys and interviews to look at how the system's interfacing. So this is we can talk more about that later offline. Oh no! All right, I'm having a little more formatting. This is embarrassing. Anyway, I wanted to talk really quick about the algorithmic piece here. As the team has also created a little bit of a framework for how do you engage in testing such systems. I'm going to use computer vision because it makes really nice slides. But I want to say that many of these principles also apply to natural language processing. They apply to time-based data. They apply to they apply to many of the other domains, audio and other things like that. Where's my? What is this word? Okay. so what we found is that machine learning things are typically brittle, and the reason why is because they don't fully understand the system or the environment that they're operating in. This Tesla vehicle, right? Many of you know they've crashed into things because they just look like they couldn't discern a white truck from the sky. Adversarial attack. This is what we consider an out-of-domain sort of thing. I don't know if you guys can see very well, but this soldier is wearing a very strange sort of tie-dyed pattern on their chest. And what that frequently is able to do is to distract a vision system from being able to detect a person, right? And so that's kind of like a camouflage, a new sort of era sort of camouflage. And then you've got other just noisy inputs that are very disruptive to systems, is that you never really thought that this would be a problem, right? It wasn't a problem for me. Why is it a problem for the computer, right? So this is kind of a crookedy street. I'm like, why aren't the lines straight? And things like this in the environment can often cause problems. So we've taken to looking at the algorithmic section and breaking it out into these categories. So this is a little bit of a vocabulary exercise. We talk about integrity testing, right? And this is the basis of where I take a portion of my data and I reserve it, right? This is a portion of my data that I've reserved. It's not available to the development community. It's specifically reserved for the test community. We found that we also want to augment that data. We want to, in order to evaluate robustness, I want to introduce blurring. I want to introduce motion blur. I want to introduce perspective transforms. I want to introduce all sorts of different deviations. I've want to introduce lighting conditions, and we refer to that as robustness testing. And robustness testing is what we call natural perturbations, things that you can expect a system to encounter just sort of naturally throughout its environment. Like something comes out of focus, you start operating in different daylight conditions, and those things all sort of change. Confidence assessment, this is really a look at what can you expect the system to be good at. What has it been introduced to and what has it not been introduced to? And so that's a competency or a confidence assessment about what it should be doing. And then resilience is what we refer to as the resilience of the system to deliberate attacks, to deliberate disruptions. Somebody shining a laser at a system, right, in order to blind it, right, or using some of these more advanced patterns to cause the system to be distracted away from its actual detection goal. Now, this is a pretty tall order, right? So we acknowledge that as you add more things that you want to be testing your algorithm against, the bill gets bigger and bigger, right, in time and manpower and in capability. And so what we've mapped is these different things, these different activities against really the risk tolerance. So if you're deploying a system that is going to be carrying people or is going to be carrying a large budget, like let's say the NASA's here, right? So you've got a system that's going to be operating on another planet. That's a pretty high risk level that you have to address. And so you're going to want to invest in the full spectrum of capability testing against the system. If you have a lower risk system that's like a chat bot, and if it goes off the rails, then it's just sort of something that it becomes an annoyance, but it doesn't really have any impact to your particular mission. Then you can just do some minimal testing to make sure that it's operating kind of as expected. And so that's what this scale is here to do. The Jake in particular, we're working on taking these concepts and deploying them in what we're calling a T&E factory toolbox. And we're working towards a minimum viable product right now. But like I said, we're trying to apply these tools and validate them against actual projects. And then once we realize that they have benefits, we want to make those available to the wider audience of the DoD. And so that's kind of the concept that we have here. Okay, so from the algorithmic section, I'll transition over to the human systems integration. This is work done by our colleagues here at IDA. And what they've done is they've mapped it to the observe, orient, decide, and act process, which is the OODA loop, for those of you who are familiar with that. And what this essentially says is that you need to identify that the operator, when you bring an artificial intelligence system into their space, and you team them with an AI type system or an automation type system, you're not actually offloading. You're offloading some of their work, but you're also introducing an additional responsibility. Because just like a squad leader has to be cognizant of what all of the members of his or her team might be capable of doing and what their strengths and weaknesses are, somebody who's using an artificial intelligent teammate, right, or a loyal wingman, or some sort of process that's helping augment their workload, they have to be cognizant of what that system is capable of and not capable of, right? And so that's very similar. So you're actually increasing their workload even as you offload some of this repetitive or redundant work, right? So it's very nice that you can take some work off of their plate, but you have to recognize that we're putting an additional cognitive burden on the person who's operating and interacting with that system.
Brian, we have about 2 minutes.
All right. Well, so we're going to skip this slide then. It was the small type, and we'll just run through the build here. So this concept is that you want to calibrate the trust, right? The user's trust in the system should be calibrated appropriately for the system they're using, right? So we have what's appropriately calibrated trust here on the left, where the user who's operating the system understands where it's good, where it's marginally good, and where it's definitely should not be used. One thing that we're seeing is overtrust in systems. We're seeing overtrust in these AI type systems. And so users just sort of accept whatever recommendation comes from such an AI partner system. And that's an overtrust sort of system. And then you've got an undertrust sort of environment too, where you don't utilize the full power of the system, where it is in fact making good choices and good decisions. All right, we'll skip here. This just basically says that human system interfacing, it does map to the ethical principles in a lot of ways, and it definitely should be looked at. So human systems integration is also a really important piece. I've had good success on some of my projects looking at how the system is helping the users and also the ways in which it's not helping the users. Maybe it was never aligned very well with the mission outcomes. Okay, so we've got a little bit of a call to action here for us here in the test community, is that test is not something that gets bolted on the end, right? It really is something that needs to come throughout the development cycle, and surprisingly also is something that needs to continue on throughout the deployment, right? Monitoring is a topic that we as a community have not fully engaged in. I say this because AI systems, even the ones that are like trained and then locked, right? So you've got a computer vision system that goes through training and then is fixed. The environment that it's in is dynamic. The environment that it's in, the seasons may change, right? From spring to summer, the capabilities of a vision system may degrade as you move through the seasons, as the environment changes. And so those sorts of things need to be monitored throughout the employment of the system, not just the development and deployment of the system. And I don't know that we're very well postured to conduct that kind of monitoring. The benefit is that monitoring will give you back data. It'll give you additional data for your feedback and training and development. Some things that I expect AI to do as we employ it in the space is I expect it to kind of find some of the shortfalls that we already have and really sort of amplify those problems. And so what we're going to see is things accelerating, like kind of a little troublesome problems that usually our human users sort of compensate for and make decisions for, is we're going to see those issues are being automated, and we're going to see mistakes sort of coming at us at an accelerated rate. And then I think we're going to see additional challenges that we did not foresee. We're going to see novel challenges that need to be addressed. But that's good, right? I think that's an emergence of capability. It's an emergence of understanding of what's possible in the space, and especially as we move into these transformational sorts of things. We're going to see serendipitous discoveries of what AI and such systems can be used for. All right, I've already hit on this. Oh, it's my time. I know Chad is
well, but you have a bottom line in the next slide that I think we really need to get there.
All right, sounds good.
Thank you. So finish up here, and then we'll skip questions and move on.
All right, thanks for the hook, Chad. So T&E is absolutely an asymmetric advantage, right? If we employ it along the mission lines, along the mission capabilities, it amplifies people, right? It can be a recommender system. It can be a task offload system, but it is absolutely there to accelerate what we're doing. And one of the key things is that perfect, right? Perfect is not what we're going to get to, but we can start to bring things that we have now into use and into employment. But we need to understand when it is good and when it is not good. And so if users know what that is, then it can be used to amplify what we're trying to accomplish. And then those operators also need to know when not to use the system. So with that, I just ask you all to think about kind of where you are in the mesh of the AI development, AI testing, AI employment, whether you're academia, industry, partners. All right, with that, we'll open. Do we have time for questions, Chad?
Thank you so much, Brian. We do not have time for questions. We started late and we didn't run fast there.
All right.
So thank you, Brian. You should track him down at lunch and ask him your questions and maybe ask him about his opinion on modeling and sim. I'm sure you'd enjoy talking to him about that.